Yeah, good evening all. So myself, I'm Vijay. I hold like 17 plus years of experience, which includes 8 plus years of experience in big data, Hadoop and Spark environment. That is worked with both Spark with Scala and Pyspark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes,
Yeah.
sir, clear.
Fine, thank you. So nice mark. What is Spark? What is Apache Spark? Why Pyspark? Need for Pyspark. So a lot of students will be asking, right? Like Spark implementation with Python or Scala, differences between them and which is more preferable. Spark Python, Scala language, Pyspark features. Real life usage of Pyspark. Real life usage of Pyspark. Pyspark job market. So yes. Yeah. What is Apache Spark? Why Pyspark? Need for Pyspark, Spark, Python 1 and Scala. Pyspark features, real life usage of Pyspark, Pyspark job market. So if we see day by day, data is increasing enormously. So if we see like huge data in terabytes or petabytes of data, right? So today industry is expecting the results in quick time, right? In terabytes or petabytes of data processing, right? To process huge data, right? So before that, I go with what is Apache Spark. What is Apache Spark? It is a open source. It is open source, distributed cluster computing, distributed cluster computing framework, distributed cluster computing framework. With in-memory computing feature, with in-memory computing feature, with in-memory computing feature, right? Distributed cluster computing framework with in-memory computing. Yes. And parallel process style. In parallel process style. Distributed cluster computing framework with in-memory computing feature in parallel process style used for large-scale data processing. Used for large-scale data processing. Yes. Distributed cluster computing framework. Distributed cluster computing framework with in-memory computing feature in parallel process style used for large-scale data processing. Used for large-scale data processing, right? Yes. It is a general engine. It is a general engine, right? For big data analysis. For big data analysis. For big data analysis, processing, and computation. It is a general engine for big data analysis, processing, and computation, right? Yes. So I said it's a open source. Most of these products, if you see, most of the big data products are from Apache, right? They're from Apache. Apache mirrors, we can just download them and we can install them, right? It's an open source distributed cluster computing, right, framework. With in-memory computing features means in-memory computing means everything within the memory level. Storage happening within the memory level and processing happening within the memory level. That's why very high speed, very huge speed we are going to see, right, within the Spark. And the parallel process style, the processing will be parallelly processed means data, whatever the data is said, data set will be divided into smaller parts we call like partitions. The partitions are distributed across multiple RAMs of multiple worker nodes and are processed parallelly, right? And they are used for large scale data processing. It's for big data analysis, processing, and computation. And you may ask why we have got already many tools available in the market, why again this Pyspark required? Why Pyspark? Simply like if you say like Pyspark, right? Pyspark is the Python API. It's a Python API. In Python, we have got a lot of modules, thousands of modules Python provides, right? This one of the API. Yes, JITP, right? Yes. Be getting the class notes and videos will be shared. Yes. Yes, Anirudh, yes, it's the same 6 p.m., right? Fine, I'll get back. So Pyspark is the Python API, is the Python API to use, is the Python API to use Spark. It's a Python API, as I said, right? Python has got thousands of modules for different environments, right? For different environments, Python language provides many modules for data science environment, for big data, networking, for testing, for different environments, it is providing many modules. So it's one of the Python API to use Spark. So it is Spark is in cluster computing, which is used for big data solution, right? So I can say Pyspark is the lightning fast technology that is designed for fast computation, right? It's one of the fast technology that is designed for fast computation. This Pyspark, I can say it's one of the very demanding tool among these data engineers, right? For working with the bigger data sets. So generally this Pyspark used for yes, distributed SQL, even in Spark we have got a component like Spark SQL. So we have got the concept of data frames where the data will be made structured and will be stored in the form of tables like rows and columns. And on the data frame, many data frame APIs it is providing, no need to write huge codings, right? And later we can perform any kind of SQL kind of querying can be done, right? And creating a data pipelines, It's a Spark is a data flow language. Data flow means like pipes. Pipe means any data operation like loading data, merging data, grouping data, transforming data, filtering data. All this at each pipe, any one kind of this transformation is going to happen, right? So that pipeline means the output of one will be the input to the next flow, right? So it's a data flow language, I can say. It's like pipe. At the end of the pipe, the output of one will be the input to the next pipe. That is one flow output of one flow will be the input of the next one. It's a data flow, right? And also
Can you please explain the distributed SQL part again?
Ingesting data into database. So here in Pyspark, right, we have got the concept of data frames. So data frames, right, which will be distributed, and whenever you can perform some kind of querying, we'll be registering this data frame like temp tables. That we'll be creating some kind of data frames, Spark objects we say, right? Like RTDs, we have got data frames, we have got, we'll be creating the Spark objects, which will be distributed, right? And if you are performing querying by creating temp tables, that will be converted, the data frame, the Spark object data frame will be converted into temp tables on which we can perform pure SQL kind of querying. Means we'll make the data structure, we'll create data frames which will be in the rows and columns, that later again we will convert into temporary tables like SQL tables and performing querying on that. So everywhere your data set or this Spark objects are going to be distributed across multiple RAMs. So you are going to fetch the data from multiple RAMs of multiple worker nodes. Ingesting data into database. And here Pyspark, as we are using Python language here, running machine learning algorithms, right? Like regression, classification, clustering, recommendations, right? And also apart from this, like working with graphs, different graph, and working with data streams, data streams, right? Like streaming data. Streaming data means data which keeps on incrementing, which keeps on generating. Such kind of data we call like streaming data, working with the data streams. Especially in Spark, we follow micro batching. This total like Hadoop and Spark meant for batch processing, batch applications, right? But for micro batching, the Spark mainly for micro batching. Micro batching means for every 10 seconds I want updates. So within the 10 seconds, what are the events generated? Processing those and providing the results. Yes. So mainly used for these things, right? Creating data pipelines, distributed SQL, ingesting data into database. Actually, in the case of Hadoop, we use a component like Scoop to pull the data from database to this any HDFS environment, but Spark directly can read data from database table. It can directly pull the data. It can take the data from SQL table, that is database table. Okay.
So here we do not require scoop if we can access from the Pyspark.
Directly like Spark, it can take data from database. If it is there in, if data is already present in HDFS, it can take it and it can process it again. It can store it back in the HDFS.
So Pyspark and Spark are different or they are similar for like same?
Whenever you are saying, see, whenever we say Spark, right, by default implemented using Scala language. Whenever you are saying Pyspark, right, that is like using Python language. So, okay, Spark is an execution model, right? Spark is an execution model. Can be implemented in multiple languages like Scala, Python, Java, or language. Spark multi-language support. It's a multi-language support, right? Can be, it supports multiple. It's an execution model, like it's a processing technology, right? Which is implemented in multiple programming languages, mostly used Scala language, Python language. Java and R language are very rarely used, but mostly used are Scala and Python. In the initial, when Spark was introduced, like if you see, if we go back like 2015, 16, 17, right? Mostly Scala language was mostly preferred. Means Scala is the native language of Spark. Scala language is the native language of Spark. By default, Spark built using Scala language. By default, Spark built using Scala language, right? But initially, in the initial like first 3-4 years of when Spark was introduced, only Scala language was preferred. But if you see in the current market, Python is mostly preferred. Python language is mostly preferred rather than Scala, as because Python, as it has got multi features, multi programming features. It has got, it supports like scripting, it supports modular programming, it supports object oriented, and that too, it has got lot of modules, modular support, and that too, main other advantage of Python is like for data science or for machine learning algorithms, right? As compared with Scala, right? Python has got great libraries for this ML algorithms, not only for that, for graph algorithms, right? It has got many libraries available, models available, right? Yes. Okay.
So what is mean by distributed SQL?
Okay. So that's what data frames are stored across multiple machines. And whenever you are performing any kind of querying, right? Any query data is going to be fetched from different worker nodes, from different RAMs of different worker nodes, right? So whenever data frame, right? It's generally data frame is going to be converted into temporary tables like SQL tables. Data frames converted into tables means the tables distributed across multiple worker nodes. And whenever you are retrieving the data, right, it retrieves the data from multiple nodes, multiple RAMs of multiple worker nodes. And here, because of this two main things, why we see very high speed processing and why we are choosing for Pyspark, right? Two main things. One is parallel processing is going to happen. Parallel processing is going to happen. If your data set is in TBs of size, it is distributed across multiple RAMs of multiple worker nodes, stored across multiple RAMs of multiple worker nodes. That is one. That is what we call in-memory computation, in-memory computing. In-memory computing. Within the memory level storing and within the memory level processing. And
So
that
data will be permanent or not? If you are storing in the memory, then is it a permanent or it is a temporary?
in the RAM you're talking, RAM is always
Yes.
volatile. RAM memory is always volatile memory.
Yes. So
So
you are
once the
saying that
execution,
in RAM it will
once the execution is completed, when the output is collected, right, there won't be any data in the RAMs. Once the
okay. Means
execution is
processing will be
complete,
in the RAM.
once the processing is done, once the data output is collected, right, there won't be anything within the RAMs. So how this computation is happening, how it is getting loaded, how this processing I'll be discussing, right? In the tomorrow session, I'll be just briefing out how these are going to be stored across multiple and how they are going to get processed and how they will be removed from the RAMs. When they are going to get removed, so yes, when they are removed only, the next data set can be loaded, right? If the data is stored permanently, the upcoming data sets can't be loaded, right? And the two, if this Spark is good for huge data, Spark is not for small data, right? For KBs of data, MBs of data, no need of Spark. Spark is for huge data, and the two for batch applications. The batch applications, Spark is for batch applications. Spark is not for online applications. It's not for online applications, right? Immediately performing one transaction, no. Spark no not required for that. For huge millions and trillions of records, storing and processing, and later you performing some kind of analysis and applying some kind of ML techniques on it and analyzing for those things. Spark, that's what we call batch processing. Batch processing means, what do you mean by batch processing? where user interference is not required, where user doesn't give any kind of input. Online application means compulsory user gives the input. If you're booking a movie ticket or if you're making a online transaction, money transaction, right? Compulsory user gives the input from which source to which destination, right? So even Spark, if you want, you can also perform online processing also with combined with NoSQL databases, right? Where NoSQL when Spark combined with NoSQL, it can perform online processing. Right, and also Spark is for real-time processing, we say, right? It is also meant for real-time processing. Then and they're detecting any fraud transaction is happening, right? For that also, because at one end the events are generating, at the other end, right? Spark will be processing with high rate of speed. So I said, right, streaming data streams, streaming data. What do you mean by streaming data?
And sir, you are saying
Yes. Streaming data means live streaming data at one end, right? Data is being captured, events are captured. At the other end, the data, whatever is captured, should be
you
processed.
told that
Hmm?
right.
1 second. See this, observe this.
Sorry, sir. Actually, I got confused. So actually, Spark is not used for online streaming, right? Hello.
One lakh events means the speed at which the events are generated at speed at one end. At one end, the events are generating. At the other end, we need to have a processing technology which will be processing these events at a high rate of speed and giving the results. Right?
Sorry,
What?
sorry, sir. Sir, Spark is not used for online means what is mean by that? Here it is using the online processing, right?
Say if you are making one, okay, you see request response architecture, we say, right? Request response client server means this is for a web applications. We won't create any kind of web applications using Spark, right? Spark is not for any kind of creation of web applications. Whenever you give a request, getting the response for those, we never use Spark. So when we go for like huge data, whenever you pull this data, right? From where you got this huge data? From different OLTPs, online transactional processing, right? This is database 1, this is database 2, this is database 3, database 4 means this is branch 1, branch 2, branch 3, branch 4. This is in Pune, Mumbai, Chennai, Hyderabad. From different branches, you are pulling the data into one place. That generally we use HDFS, Hadoop Distributed File System. Means it's a huge storage systems, right? Unlimited data storage is possible. Means from where you got the data, initially there won't be any data in HDFS. Initially, you will going to pull the data. So using okay, some Scoop components, other things, right? Data ingestion tools are there. Kafka is there. Scoop is there. Flume is there, right? So using some tools, we'll bring the data from different data sources, from different branches, from hundreds of, think that some 100 branches you got the data, huge data you got. On this data, you will apply some business logic there and to be processed at quick time, right? Spark. Huge data, like millions and trillions of records, you will apply some business logic and process and gives us result. But for single transaction, for single record means just if a client giving a request, giving the response for this kind of online transactions, right? Where user gives the input, immediately getting the output. For the small data, right? We want to go for Spark and say. For just KBs of data, MBs of data. For huge data, that too for batch applications. And also we can use for real-time processing. Spark can be used for real-time processing. Means it can also be, we can be also used for then and there detecting whether it's a fraud transaction. One second. Whether it is a fraud transaction or not. Yes, for that kind of purpose also we can go for Spark. So batch processing or for batch application, right? Spark is meant for. And
Sir, you are saying ingesting data into the database means without scoop we can pull data into the database. You are saying like that.
yes.
In this case, what will be the source? Means we are putting data into the database. Then what will be the source?
So one second. So I'll take data from different from HDFS. I've taken that input. Spark has processed the data. Directly Spark can output, means Spark can write the data to database.
Means we can do in a reverse way also.
Reverse way also, Spark can take that input from directly from database. Spark can directly take data from database. So just by providing that database related details, the Spark can directly connect with the database and it can take data as input and process it. That is possible without scoop. Okay, need for
Means
yes.
if you are using scoop, then it means that if we are using five, then we need scoop for doing this operation.
Generally, when to go for scoop? See here, this is Hadoop distributed file system, right? It's a file system where it can store huge data, right? Yes. When scoop required?
For to pulling data into the
Database.
from the database,
From database.
right?
See, SQL Hadoop.
Hadoop.
Hadoop means HDFS. The first two characters and last three characters of this forms scoop. This is only for Hadoop and SQL only. For database and Hadoop only, this scoop is used. Scoop import operation we do. Scoop import operation from database to HDFS will import, bring the data, and later this is file 1, file 2, multiple things, you will merge it here. Later Spark can take that as input. Means using scoop you are bringing here from different databases, right? Database 1, database, here scoop required from different data sources if you want to pull the data into HDFS, right? Yes.
So you are saying that we directly by using Spark we can put the data into the database. Means we are eliminating HDFS here.
Directly from one table, from one database, you can Spark can take it directly from one database. But here this is Pune branch, this is Mumbai branch, this is Chennai branch. So from this it can connect it. But I want to process, take this entire data from all the branches. From all the branches means it cannot. From all the branches take the data means Spark cannot take from all the branches.
Why?
From one branch it can connection between this. Spark can connect with this. Take the input from it, process it, and gives the result. But if you want from some 20 branches, take the data means there will be one storage system like HDFS. First store in this, all that, bring the data into all this. Here itself we will write, we can merge this into a single file. Merge this into a single file and take is at input. Spark can take as input. Okay, and give the
But
result.
by doing separate database connection, we can pull the data, or it is not possible. But that file will be the different one. You are saying like that.
See,
without
Spark can connect to a single database directly. But from multiple databases, if you want to pull it, cannot have nothing. For that middle, you will be having this HDFS, distributed systems.
And
That
means
system
if
will
we are
be-
if we are using scope to get the data into the HDFS, then also we can connect only the single database, na? At same time.
Here, once you get the data into HDFS, here it will be like a table, right? Here it will be like a table. Once you get the data into HDFS, the table become like file. Here,
Right.
from 20 databases, you brought 20 files. Later, what you will do? We'll write some logic. We'll write to merge all this file into a single file. Understanding? From Hyderabad branch, you got file 1 of 100 records. File 2, like Pune branch, 100 records. 20, nearly like from 10 branches, you are getting 100, 100, 100. Totally 1000 will be merged as one, and that will be taken as input by Spark.
So what is the data coming into the Spark? What we can say to it means what we can say to that storage system? Is it any word to it?
So here it takes the input. It takes the input from HDFS. We'll use the path of HDFS where exactly this file is available. Where exactly that file is available, right? That file path will be giving. While Spark reading, right, we'll give the input, that file path.
Okay.
After that, we'll be providing some business logic here. We'll be processing it as per that. The output, whatever you are getting, right? I will again store it back in HDFS.
Okay, means we want to change the output. We want to do some processing, so that's why we use the Spark here. But data itself in the HDFS.
Spark is not a storage system.
Yes.
Spark is just a processing it's a processing tool, right? Processing technology, right?
Whatever things we cannot do in HDFS, we can do in
HDFS is a storage system. We won't perform any. It's just a storage Hadoop distributed file system. It's a kind of file system for storing data, and this is for processing. HDFS previously we used to have MapReduce, right? But as it has got outdated, now we are going with Spark. For storage, Hadoop HDFS, and for processing, Spark. And for coding and for implementing, we use language like Python, Scala. These are mostly preferred.
So Spark is a framework where we are using Python or Scala to process the data.
Spark is an execution model implemented using Python.
So can we say HDFS as a database, because you are saying that we are storing the data into the HDFS. So why we cannot say it is a database, HDFS? Or is it like a database?
The drawbacks of databases are overcome by using HDFS. The drawbacks of databases, it's not a database. HDFS is not a database. It's a file system. The drawbacks, we have got some drawbacks with the databases. Despite of the drawbacks, we are going with this HDFS file system. What are the drawbacks? Main drawbacks of databases is it can only store structured data. Databases can store only structured data. So HDFS can store any kind of data, right? Structured, unstructured, semi-structured data. That is one. Secondly, like we see databases, limited storage. Databases, they have got limited storage. We cannot store huge data, but HDFS, we have got huge data, right? That is another thing.
So you are saying that in database, we cannot store like a file data. So we store the row and columns format. So it is possible in the HDFS, you are saying.
In databases, in a structured format only, the data can be stored, rows and columns. Unstructured data, like for example, semi-structured data, like XML kind of data, like JSON kind of data, key value notation, those kind of data can be stored. But in HDFS, we can store all those data, right?
So storage volume also will be so high in the HDFS as compared to database.
What is it? HDFS is for huge data storage. Yes.
Right.
In HDFS, we can store images or not? Images, videos.
Yes.
That we can also do in the database, no? We can store images also, videos also.
No, right? In database, we can store only the structured data, right, sir?
Yeah, only structured data can be stored in databases. Semi-structured, unstructured can't be stored, right?
So images and it is the same structure like that.
Need for Pyspark. So, okay, what is the need for Pyspark here? What is the need for Pyspark? So, a large amount of data is generated through offline and through online, right? Large amount of data is getting generated through offline and online. The data, whatever data is generated, right? It contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful business info. For example, you are given some URLs. For example, today, like some users have visited some sites. For example, they want to learn any technology, right? There's some sites were visited. So I want to just know the user preferences in which technology they want. Otherwise, I want to check their more number of clicks, which has got more number of clicks. I want to just count it, or I want to know the user preferences, right? And other useful business informations I want to just perform some kind of analysis, right? So for that, it is necessary to extract valuable information or useful information from the raw data that is provided, right? Yes. So we require some efficient tools for performing different types of operations on this huge data, big data. If huge data is given, right, if you want to perform some kind of analysis, some different types of operations on this huge data is very difficult. So there are various tools. Already we have got many tools in the market to perform multiple tasks on the huge data sets also. But the tools are not so appealing, right? So we require some kind of flexible tools or scalable tools, right, to crack this big data and to gain some benefit from it. So Pyspark is such a kind, right, where it can extract the required data. Yes. So for
So
this,
basically used for transformation.
yes, exactly. Transformations are there. Pyspark is providing many inbuilt transformations for performing all different types of transformations like filtering transformations, merging transformations, many grouping transformations, many types of it has got many inbuilt transformations. Yes. Transformations are there, actions are there. Especially in Pyspark, we see like inbuilt transformations, inbuilt actions. So actions are something yes. So combining Python and Spark would be the more efficient way for the world of big data. That's why Apache Spark community came up with a tool called Pyspark. So Apache Spark community came with a tool called Pyspark, right? Pyspark means like Python with Python plus Spark. So Python API to use Spark, right? Pyspark. And
That means you are saying like that the Spark is a framework where we process the data by using Python language.
yes. So for coding Spark, right, we can use multiple languages. It supports multiple languages. Python and Scala are the mostly used. Even Java and R language also supported.
Means if you use Scala, then we can say Spark. If you use Python, then we can say PySpark.
Whenever you are saying only Spark means implementation in Scala, if you are saying PySpark means implementation in Python. Means a Spark by default built using Scala language. So yes, here Python and Scala. Most of the students ask, right, which language is mostly preferred for implementing Spark? So just observe here. If I take Python and Scala, both are equally used in the industry, right? I'm not saying like Scala is not used. Yes, Scala also preferred. Python is an interpreted and dynamic typed. Python is interpreted. It's an interpreted and dynamic typed. Yes. What do you interpreted means? Line by line execution you are going to see. See, previously I said, right, previously like Scala is used a lot. Scala was used a lot, but now Python is used much. Now, Scala is statically typed. It's dynamic typed. Dynamic typed means generally, if you see in Python, X is X. Whenever you are saying X, right? In Python, whenever you are saying X, what type of variable X is means what value you are assigning. Based, if you are assigning a list to it like 10, 20, 30, a list is created dynamically. Means what is X? A list. How we are saying it's a list? Because what you are assigning to it, based on that only, it's going to get created. If X equal to 4.5 means as you are assigning a float value to X, so X is created dynamically. A float, as you have assigned a float value to X, a float variable is created here. X is what? Float type. Why it's float? You have assigned a float type. But if you see in Java, or if in say in Java in this Scala language, right, you will be specifying int X, float Y. But in the case of Scala, we use var or var. We use var. We use keywords like var. We use keywords like val, right? But here we won't use anything. Directly we'll assign X value as 4.5, X value as 10, or X as string. So based upon the value assigned, the variable is created dynamically typed and interpreted. Scala is compiled and interpreted. Both. Scala is the scalable language, which is extensible language to Java language, right? Okay. Python has a huge community. It's a like PSF, Python Software Foundation, and here the Scala community is smaller. And if you say Python, if you see Python comparing Scala is only used for Spark environment. No other environment using Scala language, but Python, every area Python is used in data science, machine learning, deep learning, or in big data, Spark, in web applications creations, in writing automation scripts in IoT, robotics, in DevOps environment, writing scripts in Python, right? So different areas are using Python, but Scala is used only within the Spark environment. No other environment uses Scala environment.
Which one is first?
See, Python was introduced in the year 1989, more than 30 years
No,
ago.
means in terms of speed, means processing speed, which
Yes, good query, right? Python and Scala. Python is, frankly speaking, right? Python is slower. Python is slower than Scala. Python is slower than Scala. Scala is 10 times faster. 10 times faster than Python. Scala is 10 times. Frankly speaking, right, Scala is faster because Python is interpretation language. Line by line execution happens. Scala is faster. 10 times faster. Python is slower. But this is not I cannot say it's a drawback of Python, right? I cannot say it's a drawback because of the speed. No. And Python contains and one more drawback, right? One more advantage. Python contains powerful libraries.
So, what is the meaning of statically typed language? Scala is statically typed.
We need to define the data types, right? Compulsorily, we need to define what is X, what is Y. What is X, what is Y? Compulsory. Here we need not to define anything. Directly we say X has 10, X has 4.5. But in Java Scala, right? We need to specify what is X. Int X, float X, string X, in that way. We need to compulsory define what is the X. But here we know to define.
If Scala is
dynamic-
10 times, if Scala is 10 times faster than the Python, then I think we could have to use the Scala rather than Python, right?
Hey, see here, one thing, only for coding purpose, we are using this language, right? Only for coding wise, we are using this. To code that language, we are using this Python. But it's not for processing, right? For processing, everything taken care by Spark execution model. Don't think like Python. Generally, Python is a processing and Scala is all these are processing languages. Python, Scala, Java, all that. But just we are using Python here just for coding purpose. For processing, everything taken care by Spark. Spark execution model, everything execution model by Spark execution model, Spark processing tool, everything taken. But only for coding, we are using this. But only as one thing, as I said, but I cannot say that will be the drawback here in Python.
I mean, that means that Scala internally used that, I mean, Spark internally used that Scala language, right?
Yes, yes.
For processing.
So even one thing I'm saying, right? Even when you are using Pyspark, right? See, Scala is nothing but extension of scalable. Scala means scalable language. Scalable means extensible. It is got extended version of Java. Scala is what extension version? It's the extension version of Java. So here also it has compiled and interpreted language. Scala is both compiled and interpreted. Both it is going to have compilation and interpretation is going to happen. So here also, whenever you are working with Pyspark, whenever you want to install Pyspark, Java required, Java software required. Everything Spark, everything with Spark to install Pyspark, Java required. Why, you may ask, we are not using Java language, we are not using Scala language. Why again Java software required to install this Pyspark means Scala by default built by using Scala. So compulsory, we need to install first Java to install this Pyspark. So everything runs on top of Java. Total big data, Hadoop, Pyspark, everything runs on top of Java. So internally, everything, the coding, everything we'll be using Python, but internally, all that the process, right? All the process are Java processes only. Yes.
Means at the background, whatever the processes
Yes,
happen,
instantly.
it
What
is
are
by
the
using.
whenever we say JPS, right? What all that process of Java process, related
right.
process only. But everything we require that. But don't think. And one more, previously there was a component called MapReduce. People, there was a big hype. If you see in 2012, 13, 14, big data like Hadoop with MapReduce, right? Where a lot of Java people who has got knowledge on Java only used to update with big data technologies like Hadoop, right? If they got knowledge on Java only, because total coding, they used to write a lot of Java codings previously in MapReduce, Hadoop with MapReduce, right? Slowly, people started migrating into other technologies because of huge codings in this MapReduce. Huge codings. If you see the Java means it very big, huge codings, right? Slowly, the MapReduce component totally got outdated. It is also an execution model, MapReduce execution model for parallel processing, right? But it totally got outdated once Spark is introduced. Initially, I say in 2015, 16, 17, Spark implementation was only on Scala language, not Python was never used. Slowly from last, if you see from 2019, 20, 21, like Python, whenever this ML algorithms, ML techniques, right, where Python is supporting those kind of ML techniques and it has got good libraries for it. So Python is preferred, where Python can be used for coding purpose and also providing that modules for this data streams and for this ML techniques, right? So Python is preferred there. Yes. So now slowly the industry has moved towards Python, right? Previously, I used to take a lot of Scala batches, Spark with Scala batches. Now totally many Python batches. For every 5 batches of Pyspark, only 1 Scala batch I'm taking. So even the usage of Scala has decreased. Okay. It contains mainly Python contains, what is the other advantage of Python? Contains powerful libraries. It has got powerful libraries for ML, machine learning, and for graph algorithms. The main thing is Python has got 89,300 inbuilt modules for different domains, right? That is the major advantage. ML and for graph algorithms and for data streams. Scala has no such libraries, right? Scala also, it provides libraries, but not that much powerful libraries we won't see in Scala. Scala has no such. See, and one more thing, there was a technology called Flink. Immediately after introducing of Spark into the market, right? There was another technology which Apache has introduced, like Flink. Slowly, people who has updated with Spark, if you see in 2016, 17, people who have already got updated with the Spark, right? And there was a big, the rumor was going like Flink. There's a technology Flink dominating Spark, and people said that Spark will be going away from the market as Flink is dominating, right? Flink is dominating Spark. Yes, it was real, right? Both Flink and Spark, both are from Apache only. Both are Apache products only. Both purpose, objective and purpose, both are same. Both are for processing. But Flink was dominating. It has got powerful libraries, and thus the processing speed of Flink compared with Spark was high. But initial versions of Spark, it was very weaker in the case of data analytics. Initial versions of Spark, right? It was very weaker in the form of data analytics, right? But the heart of data analytics is a machine learning, right? All this, it was very weaker. But Spark has introduced powerful libraries, very powerful libraries from 1.6 version onwards. From 1.6 version onwards, it has introduced powerful libraries, which is almost equal to, which made equal to Flink. And when Spark 2 version was introduced, it dominated Flink. And before Spark 1.6, it was weaker compared with Flink. Now Spark 3 version got released, right? Many libraries were introduced, many Spark libraries, many built-in things are available. So you won't see the word Flink now. Okay, both are Apache products only, right? So Python contains powerful, main thing that Python contains powerful libraries for machine learning, right? We have got many modules like Pandas module, Matplotlib module, NumPy, numerical Python, Matplotlib, CP, scikit-learn, like many modules available, right? Even Spark is providing many many kind of libraries for it, right? We can just import it and use it in it. For example, like any for statistical things also, right? Pyspark is providing many libraries for just a kind of linear regression, non-linear regressions, for kind of regression analysis, classification, right? We've got many inbuilt functions you can see in Spark. No need to write huge codings. Coding wise, you see, right? Coding wise, it looks very simple and easier. Pyspark looks very simple and easier coding wise. Very, very less coding you see. See, very simple, right? If you take Java, if you take Scala, if you take Python, see coding wise, how simple Python. In Java, if you say index you say compulsory. In Scala, you can say var x. In Python, we say just x. Int x equal to 10. Here in Scala, we say var x equal to 10. Var or val, we say, right? In Python, directly we say x equal to 10. So here, simple syntaxes in Python, and many libraries, many models are provided. Powerful libraries, especially for graph streaming and machine learning. The only thing is it's okay, it's lower than Scala. It has huge community and is dynamically typed. Yes. So as compared with, I'll also just discuss in tomorrow's session, right? As compared with many other technologies, Spark as compared with many other technologies, what advantages you are going to see within it. Yes. See like Pyspark features. Pyspark features, right? Yes. Okay. We have got a lot of features, Pyspark features, right? Lazy evolution, partitioning, persistence, in-memory computations, immutability, right? I'll have a separate discussion on this. It takes a lot of time for that. What are the features of Pyspark as compared with other things? The tomorrow session, I'll brief you much about this Pyspark features. Lazy evolution, it has got active evolution. Lazy evolution means Pyspark is lazy evoluted. Pyspark is lazy evoluted. What do you mean by lazy evolution? Active evolution means whenever defined, immediately executing. Whenever it is declared or defined, immediately executing, we say active evolution. For example, today, okay, the class has happened, you are running, you have taken notes. Immediately after the class, reading the notes and analyzing it, it's what? Active evolution. But not like that. Lazy evolution means whenever after 1 month exam is kept only, then only you will be reading it, it's lazy evoluted. After 1 week, if an exam is kept, or after 1 month exam is kept, then only I will read all this. That's what lazy evoluted means. Which one is better means lazy evoluted only. Why lazy evoluted means? On demand executing. On demand executing means when exam kept, on demand you are reading. Means, for example, just like a function, right? When required only, I'll make a function call so that the function executes. Every time I cannot, no need to execute it, right? Whenever on required, on demand executing. Lazy evolution is nothing but on demand executing. You are defining a data flow. Right? Whenever on demand only, you execute the data flow. Whenever you will perform some kind of action and you will make it execute. That is what the on demand execution, that we call it as lazy evoluted, one of the important feature. And as I said, in-memory computation is one more important feature we see. Memory level storage, memory level, not disk level storage and disk level processing, right? Memory level storage and memory level processing. One more important feature is persistence. We have got a lot of discussion. I'll just brief you in tomorrow's session. One more important feature of Pyspark is persistence. Means already executed transformation output, you can reuse it. Already executed transformation output, right? you can reuse it again. For example, 20 steps are there. Step 1, step 2, step 3. Tomorrow, one more problem to be solved. From that first 30 steps are there to solve that. But first 20 steps are similar what we have executed yesterday. So instead of re-executing all the 20 steps again today, I can take that 20th step output directly. I can take and I go with 21 from 21st step onwards. Means 20 steps are decreased, right? Understand here? Already executed a transformation. Today I did a transformation which has got a 20 steps. Tomorrow's I got one more transformation where I require 30 steps. In that first 20 steps, same as the previous executed transformation of yesterday. So I can reuse that output of that executed transformation and I can go with 21, 22. So 20 steps decreased. That is what we call persistence. But I'll give much more knowledge by taking some examples in the tomorrow session, right? Yes. And if we talk about the real life usage, real life, we got many real life usage of this Pyspark, real life usage of Pyspark. So if you see in that today, if you see in commercial sector, right, most of the commercial sector, yes, this Pyspark is preferred. Commercial sector, right, which uses Pyspark real-time processing systems. Banks and other financial fields, they use Spark for retrieving customer social media profile and analyzing to gain some kind of useful insights from it and taking the right decisions, right? And also in credit risk assessments and other things, right? Spark is playing an important role in fraud detection also, using ML, machine learning tasks. And even today, like in healthcare also, right? Today, if you see in healthcare, Spark is mostly preferred in healthcare. So using Spark today, if you see most of the hospitals, right, it's used in analyzing the patient's records, analyzing their previous medical reports and data, by analyzing the previous reports data and identifying which patient is going to face this health issue even after being discharged from the clinic. Even a patient has been discharged from the clinic, so even by the history of the reports, we can say which patient is going to face this issue even after he is got discharged from that. And also analyzing the patient's records for analyzing this and diagnosing this, right, in the healthcare systems. Even in the entertainment industry today, right? So if you talk about the total entertainment industry is moving towards this online streaming, like the popular online streaming and entertainment platform like Netflix. Netflix is using Apache Spark for real-time processing, for personalized online movies, for web series. Yes, it process nearly 450 billion events per day that are streamed over the server-side applications, right? Yes, even Netflix is using Apache Spark, right? Yes. For trading and e-commerce. Right? The leading e-commerce websites like Flipkart, Amazon, all this, they are using Apache Spark, right, for advertising purpose and for recommendations. People who has purchased this product also purchase this product, some kind of recommendations, right? Recommender algorithms are there, right? Yes, how to install Pyspark, all this I'll be dealing within the sessions, right? How to install Pyspark within the Windows machine, within the Linux machine, right? I'll be just showing you. And also in trade in e-commerce, right? Even like websites like Alibaba provides offers enhancements, customer experience, and optimizes the overall performance. trading and e-commerce, right? Trading in e-commerce like Flipkart, Amazon, all this they use for advertising purpose, and websites like Alibaba, all this they are used for. They're using Apache Spark. Even apart from this, there are many other fields, right? Like tourism industry. Tourism industry, it uses Apache Spark to provide advices to millions of travelers by comparing hundreds of tourism websites. Not only this, we have got many other, right? Many where Spark is used prefer, right? Yes, even we have got a separate component like Pyspark SQL, Spark SQL say, which is a module in Spark, which integrates with the relational processing with Spark functional programming API, right? Okay. So we extract the data by using SQL query language. We use the query same as SQL language, right? Fine. And okay, if you see, okay, what is that? If you see very huge course content, you can just observe this. In brief, I'll be discussing about the entire Pyspark. Just 1 second, just give me a second. So in the chart already, you can see that in the chart panel, you can see that course content link. You can see the course content link of this Pyspark. In the chart already, it is pasted by the online team. Yes. Demo link, even for tomorrow's session, if you want to join the session, the same today's demo link, you can join tomorrow's session also by using the same today's link only. And also that course content of this Pyspark and the payment process and procedure, right? Who are new to this Pyspark. And see this why Pyspark, need for Pyspark, real life usage, Pyspark, Spark session, Spark context, RTD, parallelizing, broadcast variables, accumulators, operations on RTD, DAG, RTD computations, RTD persistence, various persistence options where you can memory only, memory SCR only, disk SCR only, memory and disk only, right? And Pyspark core computations, fault tolerance model in Spark, different ways of creating RTDs, different creating Spark objects, and aggregations over structured data reduced by groupings and aggregations, single grouping, multi-grouping, single aggregations, multiple aggregations, process of group by key, reduced by key, various actions and transformations, count by key, count by value, sort by key, zip function, union, various actions and transformations, right? One by one with many working examples. Pyspark SQL data frame, right? Making data structured and using different APIs, right? Data frame APIs, creating RTD to data frame, show, row class, select, collect with column renamed where, drop, order by, group by, join, union, UDF map, flat map, for each sample, fill null, pivot, partition by array type, Pyspark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, read and write JSON file, right? And Pyspark built-in functions when EXPR, split, all these are the various Pyspark built-in functions, how they can be used with some working examples, date, format, timestamp, months between, collect list, collect set, collect map values, count distinct, dense rank, percentage type from JSON tuple, schema of JSON, right? Pyspark external sources, working with SQL statements, Spark and Hive integration, Spark and MySQL, working with CSV, JSON, narrow transformations, wide transformations, adding columns, dropping columns, renaming them, adding of new rows, dropping rows, handling nulls, writing back to external sources, creating of tables from data frames, deployments, local mode, cluster mode, Pyspark applications, stays and task drivers, executors, deploying Spark applications to cluster and tuning, right? Building Spark applications, pipelines, and performance tuning, Pyspark streaming components, Pyspark MLlib, and integration with Kafka. So this is what this entire thing will be discussed, right? Yes.
Sir, will it cover
Sir.
Apache Airflow?
No.
To
Sir,
call out a workflow, do we cover any Apache Airflow, sir?
Apache, this is what I'll be covering, right? All this. This is the course content what I'll be dealing with. So it takes so a lot of topics to be covered, right? Like Spark core programming, Spark SQL, Spark streaming, and Spark MLlib, right? This will be discussed, and also with integration with Kafka environment and many inbuilt transformations actions, right? And also like many different data frame APIs, and also integrations with the different things like integration with Spark and Hive integrations, Spark and MySQL integrations, and working with different file formats. Yes.
So when we create these
Sir,
DAGs
people talk about Flow Master, Kafka, and there are multiple things interrelated to Pyspark, right? I mean, how can you correlate all the other things along to Pyspark?
So like, okay, there's something like NoSQL and Slime Hive and Kafka streaming.
Yeah, and
like
they talk about Flow Master and all these other things. So how it is integrated with Pyspark? Can you please throw some light on that?
So yes, lot of integrations, right? I'll be covering some of those, right? Maximum, what are the things required for working with Pyspark, right? That I'll be covering.
Okay. Thank you.
So that's why I was showing you. It's not like we'll be spending a lot of hours, right? Like nearly it's 10 weekends batch. It's 10 weekends, right? It's a 10 weekends batch. So a lot of things will be covering, right? Starting from the scratch to this. So where all the installations, everything, step by step, everything I'll be showing you. Even I'll also be showing you on Jupyter Notebook, Spider ID, and on Linux and Windows environment, right? Both I'll be covering it.
How many hours a day, sir, for Saturday and Sunday?
2 hours on Saturday, 2 hours on Sunday.
And we should be done by December.
So I said, right, like it takes 10 weekends means 2.5 months.
Okay.
10 weekends means it takes 2.5 months.
Sir, does the knowledge of Python necessary before taking this, or we can learn? I mean, we can learn Pyspark with limited Python knowledge, sir.
So basic Python, core Python knowledge is required. Basic Python, even for I shall be taking a session or 1 or 2 sessions on it Python before I go with the practical part. Even I'm taking some Python batches also, right? If anyone, if you want to update in Python for an advanced concepts, right? I've got some batches going to start. Yes, on Python also.
Okay. Sure.
Otherwise, I'll be just taking 2 sessions on Python before I go with the practical part. I'll be just showing you all the syntaxes of Python, right? It's not a, it looks like normal English statements. It's not a complex language, right? Looks like normal English statements only. So that how to define all that syntaxes of Python, like I'll be taking a practical session on that, right? Yes.
Okay. And based on that, we can develop skills on that as Pyspark as well.
Yes.
Okay. Thank you.
So tomorrow also you can attend the session, right? Same time at 6:30 to see more on this Pyspark, right? And mostly tomorrow I'll be discussed, right? Spark object, like how it is stored, how it is processed, right? More discussion on this. Fine. You can follow the same link, same time tomorrow, right? Yes.
Sir, our regular classes also same time, right?
Yes, same time.
Sir, will you take any real-time project?
So I'll be showing one flow execution, right, at the last. Okay.
And is there any cloud?
Cloud, okay, at the last I'll be showing you how you can run these things on the cloud basis also. So I'll be showing you on Databricks how to execute these things within the Databricks environment, right?
Sorry to ask this generic question. Suppose, like, if you miss a particular class, I think we will be receiving any links where we can
Hey.
review this.
Every session video you will be getting, right? Every session video you will be getting to
Okay,
your Google,
okay,
to your Google Drive.
okay, okay.
It's not downloadable, but you can play and view it.
View
right?
it anytime. Okay, okay.
So yes, every session or like a Saturday and Sunday you have missed. This week you didn't attend because of some job timings or any other, right? Because of the ill health, you can just go through the video by the next week, right? And for better understanding of the next week, right?
Okay, okay.
So the notes also, clear notes also will be provided for all that whatever I'm discussing, right? Step by step notes.
And I mean, I know like since only this is on weekends and we have only 2 hours. Any questions if you have?
So 1 second, even some weekends, if I got time, I'll be just extending the sessions, right?
Yeah, yeah.
Yes.
I mean,
it is interactive sessions, right? Interactive sessions,
yeah,
you
sure.
keep responding then and there. If you got any query, you can ask that immediately. You
Okay.
can unmute and you can ask that query. No need. Right?
Okay, sure, sure.
Okay, fine. So if I'm done with your queries, I'll sign off for now. Meet you tomorrow, same time at 6:30, right? Yes. Fine.
Thank you.